So welcome to this webinar now officially. Today we will present the results of the Tampering infield surveys. These results are not yet public, so we will see what we can share after the webinar. But this deliverable basically will come out, and all the results will be shared in public deliverables soon. So this is great. Some information about the rules. So this workshop or webinar is recorded, and all the publicly available presentations will be shared on the Lens website afterwards. I will try to do this as quickly as possible, and if you have any questions, please write them in the chat. Let's avoid the Q&A function, because in the chat it is much easier, so people could actually react on your question in case there are some further details. And if you need further information after the webinar, please contact either my colleague Fanny or myself by email, and we will talk about the Lens project itself very briefly. This will be done by my colleague Orke Stjördin, and then we will talk about the test setups and the interpretation of the test results, both for noise and air pollution, and then I will briefly wrap everything up. Yeah, I hope we will have a good conversation, and don't hesitate to write your questions in the chat. I will read them out, and we will probably have a great engagement here. So I will give the floor now to my colleague Orke for the introduction to the Lens project.
Thank you very much, Niklas, and welcome everybody to this webinar. I will share my screen. I hope you see an introduction slide.
Yes, we do.
Thank you. So yes, I will just briefly present the Lens project as a whole. Lens stands for L Vehicles Emissions and Noise Mitigation Solutions, and it's a Horizon Europe Research Innovation project with a budget of about 5 million euro. We are 15 consortium partners consisting of research institute, universities, and also quite a few numbers of OEMs, and also an instrument manufacturer. The project started in September 2022, and it will be completed this fall. So there are a lot of results coming out, and you can expect to find public reports on our website shortly. Quite a few ones coming up in the next couple of months. Yeah, just a brief background. As you may know, L vehicles mostly do not require regular inspections, and the type approval emission tests are done only in laboratory conditions. And we also know that cities, to a large extent, they lack L vehicle specific mitigation policies. And we also know that especially noise pollution from LVs can be a big problem in both urban and rural environments. So that's why we have initiated Lens. The objectives are to develop beyond state-of-the-art pollutant emission and noise measurement techniques for onboard, on-road, and roadside measurements. And then use these instruments, these techniques, to characterize noise and pollutant emission performance. And now what we are going to present today, the in-field identification of tampered LVs in 3 cities in Europe. And in the end then based on all the research, provide recommendations and estimate the expected impact of decreasing noise and pollutants from vehicles. So what we are doing and have been doing is to go through all types, the very broad category of vehicles, from the smallest two-wheel mopeds and scooters to high-performance motorbikes, and also these kind of strange vehicles with 3 or 4 wheels, small vehicles. And altogether, one main scope of the project is to measure the noise and pollutant emissions from 150 LVs in the lab and/or on the road. So it's a quite extensive measurement program in this project. Few years ago, we did one of the first reports coming out of LENS was a survey, a desk work, but also a survey where we interviewed a lot of people, drivers, motorcycle clubs, and so on, to find out a little bit more about how the situation looks in the EU regarding tampering. So we had, I think, more than 600 samples and data from information from 20 EU countries, coming up with some interesting results. And this report is available as a public report on the LENS website, so you can download it and read it if you're interested in that. So then I will continue with the measurement campaigns that we carried out, give you an overview of that. We did 3 city measurement campaigns in last year. We started with measurements in Leuven in Belgium in May. Worked together with the police there, and we did not so many measurements because they are not so crowded of LVs like in other cities, which I will show you later. But we managed to do emission and noise measurements on about 250 LVs, and as much as 165 of them were inspected at the roadside, pulled over and inspected. Then we continued to the Paris region, in a suburb to Paris, Rueil-Malmaison, and sort of a scenic site some 50 kilometers outside Paris in September. There we made about 950 measurements on LVs. Regretfully, we did not manage to have any roadside inspections carried out here. This was only due to the fact that this campaign followed very closely on the Olympic Games and the Paralympic Games, which meant that all police resources were working hard July and August, and they had to have their vacation period in September instead. So it was a bad timing, but we had no other choice. And then finally, in October last year, we went to Barcelona and we did around 1,000 measurements there also. And here we had good help from the police and the inspection company. So we inspected 95 LVs at the roadside. I will describe briefly also the instrument that we are using. We have a remote sensing instrument from the Madrid company Opus Remote Sensing Europe, which is a way of, by using infrared and UV spectroscopy across the road surface, we can measure the emissions of gaseous pollutants in the first place, like CO, HC, NOx, and some other gases. We also measure opacity PM, speed acceleration, and also it's connected to an automated license plate reader. So we will get the license plate numbers, and we can find the information on the measured vehicles through the national vehicle registries. Then we have been using, for the particle measurements, particulate matter emission measurements, we used sort of a bouquet of different instruments. 2 of them were developed at the Technical University of Graz. in an earlier EU project, and it's been further refined for this project. And we have also used a TSI engine extra particle sizer, which is commercial available instrument for these measurements. Then finally, we had the microphone noise measurement system, an array of 5 microphones that has been developed by KU Leuven, and you will hear more about that in the results section. Just before I go into some more of the results, I would like to explain to you how this works for the pollutant emission measurements. All the instruments measuring pollutants measure concentrations of pollutants and CO2 in the exhaust plume in the range of 0 to 3 seconds immediately after a vehicle has passed. And the measured concentration ratios of pollutant to CO2 is used to derive instantaneous emission factors in the unit of grams per kilogram fuel burnt. And this is by just deploying the fuel combustion equation and the measured concentration ratios that we have. And finally, we have used fuel consumption factors corresponding to the driving conditions that we are sort of measuring here in these campaigns. They are calculated, and we have used them to derive emission factors in grams per kilometer, which is more, I think, understandable if you compare with emission limits and that stuff. So this is a typical instrument measurement setup. This is outside Paris in Rueil-Malmaison. You can see all the instruments here, more or less, not all the ones that are in the van, of course. The noise system, the devices that are needed outside the van to measure particle emissions. Then we have the instruments inside the van. And we have the Opus RSD system to measure the gases emissions, and also the automatic license plate reader here. Okay. We also did in Leuven and Barcelona, combined with this measurement, roadside inspections with the help of local city police, traffic police. And in Leuven, we had very experienced LV expert from the TU Graz, Technical University of Graz, who did the testing and the visual inspections. Whereas in Barcelona, we had wonderful support from Applus, Ideada Applus, which are actually doing regular PTI testing on all kind of vehicles and motorbikes, of course, also. Yes. Just before we go into the results, I want to show you how the vehicles that we measured, what kind of vehicles they were. You can see here the distribution of the measured LVs by engine displacement volume. And for all cities combined, we have a quite fair share between the smaller ones, the medium ones, and the big ones. You can see that if you look at the different sites, it's a quite a big difference between the composition of small and big bikes. Especially Leuven had a very high share of really small mopeds and scooters, whereas in Paris we had more of the heavier ones. Also Barcelona. Okay, and then also looking at the distribution of the measured LVs by Euro class. For overall, we have quite a good split between the most recent standards. That's Euro 5, 4, and 3. They are dominating. And only fair shares, very small shares of the older vehicles. Yeah, there are some differences between the cities here, but it doesn't really matter that much because we are looking at the Euro standards per se in our analysis. And finally, a little bit about the driving conditions. Since we measure speed and acceleration, we know how they drive. So speeds are typically urban speeds, quite low, on average around 20 kilometers per hour, ranging from very low speeds up to maybe 60 kilometers per hour, depending on, and also some variations between the sites. Accelerations, quite constant speeds, I would say, but since we measure in all the three sites, we measured in an uphill slope. We have a positive vehicle-specific power on most vehicles we measure. What might be interesting here is that in Barcelona we see a small difference in acceleration from the smallest vehicles to the heaviest vehicles. The heavier vehicles tend to decelerate more than the lighter vehicles, which we may see some of the noise results later on. So now to the results. So newer LVs have much lower on-road emissions than older ones. That's the good news, I think. For CO, see downward trend. Also for hydrocarbons, maybe not that pronounced. And for NOx. If you compare the oldest vehicles, Euro 2 ones here, with the newest Euro 5, we have a downward trend for CO of almost 90%. For hydrocarbons with 80%, and for NOx with 60%. And we can compare this, how the Euro limit has developed from Euro 2 to Euro 5 or Euro 3 to Euro 5. For CO, it's been down with 91%, from the very oldest one to the newest ones. For hydrocarbons, very similar. And for NOx, can I do this? Oh, sorry. I hope you see it. 80%. So it's a bit lower in on road, but you must mind here that there are rather poor statistics. You see this, the error bars here, the standard errors. So it's a big uncertainty in these numbers. So, but I mean, the overall message is that new LVs are really much cleaner than the older ones, and that's what we want. And you also see these in the roadside inspection idle tests. You can see that the CO concentrations at idle and hydrocarbons has gone down with about around 85% from Euro 2 to Euro 5 for both CO and HC. Then we have, I hope, some results for particulate matter. Here we see maybe a bit complex figure, but if you look at the black circles here, you see the averages of the PM emissions in milligrams per kilometer, how they have evolved from Euro 1 already to Euro 5, a very sharp drop. And it seems like it's below, the average is below the Euro 5 limit. If we look at the particle number, well, we don't have any emission limits yet for L vehicles, but we have for a Euro 6 cars. It's also a very sharp drop, and the conclusion is that if you compare to the Euro 5 vehicles, the on-road emissions of PM and PN are 2 orders of magnitude higher for PM and 3 orders for particle number, the smallest particle number smaller than 23 nanometers. So this is really good evolution, I would say. Then we have tried to analyze the impact of tempered vehicles. in Leuven, based on the roadside inspections, we found that about 11% was modified or tempered in some kind of illegal way. And the various different tampering approaches is here distributed quite equal between those that relate mainly to noise and those who relate to emissions, exhaust systems and mufflers. Quite interesting is the results that we see in Barcelona agree very well with the results in Leuven. Here we had a bit more sort of advanced testing or inspections at the roadside, so we can differ between more tempering or modification methods. So we can see that the 33% of the tempered vehicles were above the reference noise level according to the stationary noise test. The exhaust system was modified or tempered in 24% of the cases. No dB killer in 24 also. So there is quite a lot of things that could impact on the noise levels. Okay, and how does these kind of modifications and tempering affect on road emissions? Yeah, quite substantially, although we don't have much data, but if you compare the not modified LVs, which were about 100 in total, with those that were modified or tempered in some way, and especially if you look at those where the exhaust or engine was modified, you see a clear increase here if you compare the not modified with the modified ones, both for CO and hydrocarbons. And also you see a similar trend for particulate matter. This is now measured with the OPUS opacity, UV opacity. So it's not very accurate, but anyway, you see clear difference between the non-modified and the modified ones. For NOx, on the other hand, you cannot see any difference between more or less, rather the opposite, although the data are very uncertain. And of course, if you have an increase that much of CO and hydrocarbons, that means that these vehicles are going very rich. This will suppress NOx emissions, so this could be an impact of that. Finally, we try to see what was characterizing the modified tempered LVs if you look at some typical data. Compared to the not modified tempered LVs, the tempered one had a higher share of two-stroke engines. 23% of the two-stroke engines LVs were tempered compared to only 3% for the four-stroke ones. And their average engine size was higher, not double, but not very far too. You can see this also if you compare the share of modified tempered vehicles in the two weight categories below 500 cc and above 500 cc. You have a much higher share for the heavier ones. Also, the modified tempered ones had an average age that was about 2 years higher than the non-modified ones. We did not, however, see any significant differences when it comes to average Euroclass or average vehicle mileage. With that concludes my presentation. So I think there may be time now for some questions.
Yes. Guillaume Aufranc is asking, for particle emission concerns, was there any two-stroke vehicles tested or only four strokes?
You mean for the roadside measurements of particulate matter, or?
Yeah, I assume this because this is the main.
I mean, we did not do any roadside inspection tests on particulate matter, only CO and HC. And we have some data for the old or very old vehicles on the roadside measurements. So it was in the graphs. Maybe I didn't understand the question fully.
Maybe Guillaume can explain it a little bit more. But yeah, we have specific data for more than 100 vehicles but those were done in the laboratory, of course, in those tests. But yeah, what were the main types of vehicles that basically passed by? You probably cannot analyze this just by the information that you receive from the vehicles passing by, I assume, right?
I mean, it's what we measure is the instantaneous emissions on a big number of vehicles. So
Exactly. Yeah.
it's quite hard if you look at individual vehicles only because driving conditions. So we prefer to look at averages, fleet averages, to be sure that we can say something about difference between different groups of vehicles and so. So that's what we've done with Euroclass is an example where we look at average emissions by Euro standard.
Okay, great. There's another question, this time from Javier Bohigas. Could you please summarize, and we have two questions, what is an approximate share of the L category fleet to be tempered, around 5%, and how much relative or a factor of our emissions increased? Looking at the graphs, it looks like a factor of 3 or 10 times. Maybe you could go back and share the graphs that he's referring to.
Was this the right slide, or you see the
Yeah,
impact?
I think he's referring to the tempered vehicles. So yes, that, yeah, perfect.
Yeah, so if you judge by this, it's for CU maybe a factor of 5 or something. For PM maybe a factor of almost 10. CU and hydrocarbons, yeah. So it's quite substantial. Although I must note that these are not very many vehicles, so the statistics are a bit uncertain. But it's a significant difference for these vehicles that we compare.
Since I'm not a technical expert, maybe it's a silly question, but how do you assume this could happen? That for example the PM is so significantly increasing in a tempered vehicle. What are the reasons for this?
Sorry, Niklas, I'm not a very good expert at that either.
Okay. Okay.
Maybe just poorly maintained vehicles, or tempered, deliberately tempered in some way.
Okay.
Yeah.
Okay. To the audience, in case you have further questions, please state them in the chat quickly now. Otherwise, we would go to the next presentation to my colleague Hervé from K.O. Leuven. Please continue.
Okay, I will then share my screen.
And don't forget to enable the audio. I think you have done that, yeah.
I think I did. I did.
So everyone can hear the sounds. Yeah, perfect. The floor is yours.
Are the slides coming through?
Yep.
Okay, good morning. So I'm going to guide you through some selected results that we got from the noise measurements along the roadside. So maybe to start, Let's have a look at an overview picture. So what you see here is for the different measurement sites. First of all, a box plot showing the median and the percentiles of the noise levels that we measured along the roadside. And I know I overlaid these on violin plots to also show you a bit how the underlying distribution looks like. It's important to note that these levels are by no means comparable to what the limits of the type approval testing impose. To start with, there is a different distance between the microphones and the vehicle, but there are many other conditions that affect these noise limits. So it's just to give you an overview of how the different fleets at the different sites compare. And the first thing that we can observe is that for all these sites, there is quite a large overlap between the distributions. Median levels are within 2.5 dB from each other, somewhere between 71.5 and 74 dBA. Where the slightly higher levels are measured at the urban sites, where there is also a bit more background noise. The interquartile range, so where you have 50% of the fleet being represented, is consistently between 4 and 6 dBA for all of these sites. What you can also immediately observe is that the distributions are not normal distributions. They often have a heavy tail towards higher sound pressure levels with quite some outliers. And these outliers are very often due to specific driving behavior that leads to high noise levels. And for example, I brought the highest level that we measured in Barcelona. I will play it for you. So it's a vehicle that is throttling just in front of the microphones. It's a kind of behavior that is known to lead to much higher levels. So most of these outliers are due to specific behavior that is not linked to the vehicle itself, but mostly to how it's being driven. Now, to analyze this in a bit more detail, let's have a look at the division per Euro class. I have to note here that because the identification of the vehicles is done by time synchronization with the other measurement system, these graphs are made with less data. So there is a bit more uncertainty and there is quite some data loss between the first graph and this one. It's maybe not fully clear in this aggregated picture, but if we look at all sites individually, we see that for all the categories, the medians are within 1 dBA of each other, and that the IQR is almost fully overlapping. Now, that doesn't mean that no progress has been made. First of all, these figures here, they correspond to a mixed fleet, and the composition of that fleet is not uniform at the different sites or within the different categories. And also driving conditions play a very big role in the noise level that we measured, as we already saw before. And the average conditions that vehicles were passing by our measurement site were far from being the most noise critical. So most of them were driving by quite slowly, very often even slowing down to see what was actually happening. If we look at the highest levels, which are not considered outliers, there we see that the first three categories, so Euro 2, 3, and 4, they are very close to each other within half a dB, but we do have a significant decrease towards Euro 5. Can be a coincidence. Of course, the numbers of vehicles that we have here are much lower than in the previous plot. Looking at how these distributions look like if we look at different types of motorcycles. So here we group them per engine size because type approval regulations also allow bigger motorcycles to make more noise. What we observe is that looking at the A-weighted sound pressure level, we actually don't see much difference. The medians are very close to each other. The distributions are almost overlapping, which may be surprising at first sight, but it's also kind of logical because of the driving conditions. So speed and acceleration were quite consistent, relatively low among all the categories. But this also means that for the larger vehicles, they are driving by proportionally with a much lower load on their engine than the smaller vehicles. So in that sense, it shouldn't be too big of a surprise that the levels are not that different. Additionally, also the A-weighting filter plays a role here. So typically noise levels are A-weighted. It's a filter that tries to account for our human perception of sound. It decreases the importance of low frequencies quite significantly compared to higher frequencies. But it's not the only filter that can do this. There are other ones. The A-weighting filter is originally designed for quite low sound pressure levels. For example, C-weighting filters correspond to higher levels and maybe more appropriate. So if we rescale this figure using another weighting filter to account for human perception, we get a very different result. So here we do see a significant increase from the lightest to the heaviest engine or vehicle categories. This has two reasons. First of all, simply the fact that those vehicles often make more low frequency sound, but also in internal combustion engines, there are quite some frequency components that scale with the RPM. And if you drive by at low speeds, low RPM, you will also have quite important low frequency content that contributes to the sound signature. Now, if we have a look at what tampering does with the roadside noise levels, on this graph, you see a comparison between on the x-axis, what we measured with the vehicles passing by, measured from the roadside, and on the vertical axis, the stationary noise test as it's described in the type approval testing. We do this only for the Barcelona campaign because that's the one where we have the largest amount of data and to avoid any bias due to differences in location. You do see that the tempered vehicles tend to be on the top right corner of this graph, so having higher noise levels, but you can also immediately see that there are quite some non-modified vehicles which have comparable roadside noise levels as the tempered ones. So it's not simple to say that it's loud, so it's tempered, or it's tempered, so it's loud. It's a bit more nuanced. We can also here have a look at the same result, but with the roadside noise levels scaled with a C weighting filter. And it's quite surprising to see that there we get a much nicer correlation. It's of course a very small data set, but nevertheless, we do observe this. And that in this case, the tempered vehicles do stick out much more than they used to be on the left graph. So this suggests that low frequencies are most likely very important, partially due to driving conditions. People with a tempered motorbike tend to drive more slowly past the measurement site when they see police, but also due to the sound character that people try to achieve with tampering. So those low frequencies play an important role in the sound signature that they're trying to obtain. Analyzing that sound character in a bit more detail, I brought a small example. So I have three nominally identical vehicles which pass by our measurement sites. Two of them are in principle not tempered. The third one has been tampered with, has the muffler changed, and has no DP killer. So you see that there are quite some differences in noise levels, especially in the stationary noise level. There's 10 dB difference between the tempered one and the non-tempered one. On the roadside noise measurements, the difference is much smaller, only a few dB, where here you see that this is mostly due to the A weighting filter, because expressed in with the C weighting filter, the difference is again in the order of 10 dB. Besides that level, also the character is quite different, and that's why I brought the recordings as well. So I will play them for you. All these recordings have been scaled, so they are all roughly equally loud, which means that all the differences you perceive are just due to the character of the sound, not due to the level. This is the first one. Quite easy to pick the one that has been tempered with just by listening to these, despite the ambulance that's disturbed the measurement a bit. And there are also metrics that try to quantify certain aspects of that sound character, which we call psychoacoustic metrics, such as the roughness, which is in the last column of the table. So we also had a look at that kind of metrics, where for roughness, roughness is a measure for fast modulation in signal. It's something very typical for internal combustion engines, where you have a lot of tones that interact with each other and that leads to these phenomena. So for the full fleet, you see the figures here. I brought two examples. This is a vehicle with a very high roughness, and then very low one. So that's smooth or rough character of the sound. That's what we're talking about here. For the complete fleet at all measurement sites, except for the rural site in Paris, we have quite consistent results. Medians, very low roughness values, around 0.3, 0.35 for the bigger vehicles. With not too much spread on the data. We do see quite different results in Tampering and Yvelines, so where the roughness is consistently higher, around 0.5, and also the spread is much higher. Now, we didn't have any vehicle inspections there, but the site is quite famous, and it's believed that a significant share of vehicles there was tempered, although that we don't have any absolute numbers. So we also checked other metrics. I'm not going to go through all of them today, but this is the most striking result. If we then compare how these kind of metrics change between not modified and tempered vehicles, so here we again look at a much smaller data set, so only the ones where we know if they have been tampered with or not, the ones that have been inspected. We observe that there is quite some overlap between the distributions for all the metrics, but nevertheless, it seems that roughness tends to increase for tempered vehicles, and that also tonality, although it is very low for all vehicles, there is a small but significant increase for tempered vehicles. There are many other metrics that can be relevant for LV noise, and if we want to capture the full picture, there are definitely many more that we should look at. What we also did is, because there are some features, or if we try to derive a set of indicators for tampering, we need much more information. So we went beyond the conventional psychoacoustic metrics, and we also had a look at features that come from other fields, which try to characterize certain attributes of a signal that we can link to tampering. For example, kurtosis is a measure for how peaky a signal is. The maximum harmonic product spectrum is a measure for the harmonic content in the low frequency spectrums. Also those, typically, we expect them to change when there is tampering. So also there we have a nice overview of all these figures. I'm not going to discuss all of them. But for some of these features, we do see some differences, although it is always the case that there is quite an overlap between the different features. So it's not the case that you can say, by looking at a single number, this vehicle has been tampered with or not. Main conclusion is that we have identified some parameters that can be looked at to indicate whether there is a possibility that a vehicle has been tampered with in real-life driving conditions. But there are quite some conditions that influence these parameters as well, including driving behavior and the character that the manufacturers themselves try to give to the sound of their vehicles. So in order to derive a firm set of metrics or an algorithm that can detect tampering, we will need much more data than we currently have available. The data set that we currently have doesn't cover the full range of all these parameters that have an influence. And that brings me to the end of the results that I brought today on noise. Niklas, I don't know if you want to do a Q&A now, or if I first do the conclusions. Should I carry on with the conclusions first?
Yes, I think
Yes.
that's a good idea.
Yes,
Okay.
please, Stefan.
All right, so in summary of what we saw today, well, first of all, on-road emissions, both gaseous ones, and especially the particulate pollutants for L vehicles, they have on average been reduced substantially over the last 2 decades, mainly thanks to Euro 5. We didn't observe a clear evolution in terms of sound pressure levels measured from the roadside, but that's most likely to a large extent due to the driving conditions at all the measurement sites. The share of modified and tempered LVs affecting noise and pollutants was very similar for Leuven and Barcelona, in the order of 10%, with the side remark that this excludes tampering with the speed limiter, so that we didn't test. And LVs with a larger engine size and with two-stroke engines are more commonly tempered, at least in the fleets that we inspected. If we look at modifications and tampering of mufflers and exhaust systems, they tend to substantially increase the pollutant emissions compared to the non-modified state. Also, noise levels are often higher for tempered LVs, but it depends how you measure them and how you quantify these levels, how big the resulting difference is. And then modifications and tampering, they clearly change the sound character of an LV, often leading to higher roughness and tonality. There are many other metrics that could and should be looked at to indicate tampering, but we don't have sufficient data to give you a firm answer on which set of metrics you should look at to detect a tempered vehicle in the fleet. And that brings me to the end of my presentation. So thank you for your attention. If there are any questions, I'll be more than happy to try to answer them.
Thank you very much, Abby. I do not have and there are no questions in the chat basically, but maybe I can ask you a question. Um, if you would change one thing in your test setup that you have done in the three cities, let's say if you would have more money to spend on better gear, or to have more time to have more precise setup basically, what what would you change, or is there anything, do you see any shortcomings of the research that you have done basically?
Yeah, so we went in terms of hardware for a low cost solution using mostly available things, in the sense that there are quite some commercial systems available that are specifically designed to isolate the sound of a specific vehicle in road traffic. We didn't want to reproduce all that research or all those efforts ourselves. That's why we used a kind of low cost system. The main shortcoming that we experienced is the fact that we did not have or did not develop our own ANPR system synchronized with the noise measurements. So everything was done in post-processing, linking to the other measurements. And that has led to quite some loss of data. So sound signatures that we measured, but that were not picked up by the other instruments or vice versa. Or where we were not certain, like two vehicles within a too short time frame, and we were not certain which one is which. So there we have quite some data where there was too much uncertainty to label them accurately. So I think there we could have had a bigger database of noise recordings if we would have gone for a different approach. Definitely, there are more advanced systems also to isolate sound signatures in complex traffic conditions. That's the research that I mentioned before. Can definitely also help, because we had to remove quite some recordings when the vehicles were too close to each other, or there was people talking in the background, that kind of things that yeah, we had to take care of. So in that sense, yeah, in terms of hardware, there is definitely there are better ways, more expensive, or at least not available to us when we did the measurements, and it would have saved us quite some time and effort in post-processing.
Are you, or maybe to Olga as well, are you surprised that you basically had the same amount of tempered vehicles both in Barcelona and in Leuven?
Yeah, I'm not an L vehicle expert, so I actually had no idea on what to expect. It is to a certain extent surprising because the fleets were quite different. So Leuven has a lot of 50cc light vehicles. Barcelona tends to have mostly heavier scooters and a more diverse fleet, but surprisingly overall, the statistics turn out to be the same. But with the remark, of course, that the number of inspections, although it's a huge amount of work, it's not a huge number. And I also believe that, yeah, we were there for a full week. At some point, people know we were there, tell each other, if you have a tempered bike, stay away this week. So that can also have an influence on some of the results.
Yeah, makes sense. Yeah, I was also surprised, especially because when we looked at the anonymous survey that we have done regarding tempered vehicles right in the beginning of the project, there were these numbers were significantly higher. But I mean, yeah, but and of course what was also surprising, because I'm also seeing these results today for the first time, that basically that you could clearly hear the tempered vehicles in your sound examples. This was very good that we were able to hear this today, basically.
But just to give you an idea, in Leuven, I literally saw somebody seeing us and doing a 180 turn, trying to get away. So I do think that we did not, or that the numbers we got are kind of underestimations or lower limits.
Can I add a few things?
Of course.
I know there was a study a couple of years ago. I think it was conducted by Emisia, coordinator of this project, where they did a visual assessment of tempered vehicles across Europe and maybe also in other parts of the world. And I think they come up with a quite similar number, around 5 to 15% on average. But then you also have, we see in this study, we see that the bigger LVs are more frequently tempered. And we regret largely that we didn't have the chance to have the roadside inspections in the Paris campaign. So that's a sort of blind spot there. I think in the scenic spot there, I think we had find a lot of tempered ones, but we don't know.
Okay, yeah, then I think this was a very much insightful hour. We are nearly at the end of this. So you're already sharing the right screen. What I would like to highlight is basically to our audience that since now, basically now it's the time that all the results are coming out at the end of the project, because we have done the tests in the laboratories, on the roads, on the sides of the roads, and I mean the letter was presented today, but there are also other webinars as recordings available on our homepage. So our website is lens-horizoneurope.eu, or use the QR code that you already see on the screen. The same is also available for Twitter or X and LinkedIn. Please follow us, because there will be some further announcements about our final conference that we are not allowed to share at the moment, because we are still finalizing some administrative elements of the project. But we will have a final conference most likely in late late October in Brussels, and it would be great if we would see you there in person, because then we have much more time to assess the and contextualize the other results as well, and maybe also have some opportunities to have some open discussions between our very diverse project partners. That includes the research organizations, the academia, the OEMs, but also we as Polis who represent cities and regions, and also our stakeholder group. I've seen some of you here in the here online as well, and yeah, and in case you have specific questions, don't hesitate to approach us. In case we are allowed to publish the PDFs of these presentations, we will do that as soon as possible. You will also find a summary of the webinar and the recording online. We just need to clarify what we can publish already now, because the deliverables are coming out in the next couple of weeks. And as I've mentioned, everything will be on the homepage as soon as possible. With this, I would like to thank you very much for your attendance, and we will see you soon in Brussels. Or if you have any questions, please contact us by mail. Thank you very much, Hervé and Orke, for taking the time in this busy period while finalizing your deliverable. And yeah, I wish you a great afternoon. And with this, thank you very much, and have a good day. Bye-bye.
Thank you very much. Bye.
Thank you.